Welcome VR fans to another video. In this one I'm going to show you how you can stop your users peeking through walls. So I'm sure all of you that watch this channel have probably played those VR games where you try and put your head through a wall and maybe sometimes you can and you can see what's going on outside the environment, or the screen will fade to black. I wanted to take a look at how you could do this in Unity and see what was involved in putting this feature together. But let me show you what I mean just to make it super clear. So let's hop into VR and press play, and I'll show you what we've got going on in this little demo scene. So if I hit play, there we are. So you can see I'm standing in the scene. I've got using XR interaction toolkit. Just turn the controllers on, and I've got these two walls either side of me. I have set it up using the continuous move and snap turn as well, which I'll show you how to do quick. That's super easy. But then when you want to try and like peek through a wall, you go near the wall, it's going to fade the camera out. So you can't see what's going on. So now we've seen what we're going to be making, let's hop into Unity and get started. Okay, so you guys know the drill by now. Let's get XR Interaction Toolkit up and running. Windows Package Manager, add package by name, com.unity.xr.interaction.toolkit. What? Got it wrong. Damn, I thought it was going so fluid. There we go. We're going to go ahead and use a new input system for this, so go and hit yes, and Unity's going to restart. And then once you've restarted, we're going to go ahead and bring in the starter assets and close that window down. We're going to go to our starter assets that we just brought in, and we're going to add in our left controller preset. We're going to click on the add to action based controller defaults, and the same for the right. Next step, let's get this all set up for VR. We're going to go to build settings and then click on player settings. Lock that in the side here. We're going to change a few things around. Let's move this out, me over, and now we want to go to the XR plugin management and install XR plugin management. You can just use OpenXR for this on both Windows, and we're also going to do the same for Android as well. Go ahead and use OpenXR, and then we're going to drop down to where it's got OpenXR below XR plugin management, and we're going to add in an interaction profile for our Android. So we're going to click on there. I'm using the Oculus Touch controller profile, so I'll choose that one and enable the Oculus Quest support. Then under the Windows, I'm going to add in my Oculus Touch controller profile, and we are good to go there. And the last thing we're going to change is under our preset manager, just going to add in word right to our XRI default right controller and left to our XRI default left controller. That's just going to populate all those input actions. Create an XR rig. Nice. So we're all good to go now, really. We can delete the main camera from our scene. We can go ahead and right click, create our XR origin VR, and click on our XR interaction manager. We're going to go ahead and add a component, and we're adding the input action manager, adding a 1 in there in the box, dropping it down, and we're going to choose our XRI default input action. It's going to double check our rig to make sure we got our input actions, and we are looking great. We're going to need a very simple scene to walk around, so I'm going to go ahead and put a plane on the ground, scale it up a little bit, the ground, and I'm going to create two walls, and these are going to be the walls that we can use to test our head, to see if they're going through stuff. So we're going to create, I'm just going to create a cube, use the rect tool, and make it look like a wall, like so. Two walls. On my walls, I'm going to go ahead and add rigid body to these, and I'm going to uncheck use gravity and his kinematic. Now we're all good to go. I'm going to put my art in an art folder, save my scene. So this is really going to be made up of two key elements. One of those is a quad that's going to be drawn near the camera's near plane. The next is a script that's going to do like a physics sphere cast out into the scene to see if we've collided with anything. And then we're going to create a shader that's going to draw over the top of everything else in our scene, so that when that quad's visible in front of us, we won't have that clipping effect, so that we can see a wall going through it. So three key elements that we're going to be working on. The first one is the quad. So let's go ahead and have a look at creating that. What we'll do underneath our XR origin, we're going to select the main camera. Going to right click and create a quad. This is going to be quite big. Want to make sure it's obviously facing the player. But we can go ahead and reduce the size to like 0.5, 0.5. We'll leave that scale alone on the Z. At the moment, where this quad is sitting, it's too close to the camera that it won't be seen anyway, so we need to push it past the draw distance of the camera. If you select the camera, you'll see that our near clipping plane is at 0.01. So our quad needs to be slightly greater than that number. So we can move the Z position to say something like 0.015. Select the game view, you can see there that I can't see anything. There's a big quad right in front of the screen. If I just grab the headset and if we just hit play quickly, there we are. So now we're in VR and you should be able, that quad should completely obscure the vision. So just need to quickly just check that's all right, which it is. So on that quad, we can take off the mesh collider. We don't need it. We don't want it to cast shadows, so we'll turn that off. And probes, light probes will turn off. And we don't want any dynamic occlusion, so you can go ahead and turn that off too. You can give this a name. We can call it something like camera overlay. And we've got our quad all set up. So next we need to have a look at the material on that quad. I'll go back to my scene view. If we give our walls another material, I've created a material here called Enviro. We'll just drop on. I'm going to make this easier to see. We're going all the way to the ground. There we go. So what you'll notice is that all the geometry is going to clip through. When I move around that plane, if I clip anything, I'm going to get that geometry clipping through my plane, which we're going to be able to see. But I need that plane to be always rendered on top. So no matter what, if something clips it, doesn't matter, the plane's always going to be rendered. And you're not going to get that clipping effect. We're actually going to create a very simple shader and shader graph that we can put on our plane that's going to allow it to be drawn on the top of everything. So let's go ahead and have a look at creating that shader. Right click in my project and then go to create shader graph, URP. I'm going to use the unlit shader graph. Call this camera overlay shader. And we're going to create a new material. Call this camera overlay. And drag and drop that onto my quad. And then on that material, we'll drop it down and we'll go ahead, go to our shader graphs and we'll make it use our camera overlay shader. Then we need to double click on our shader to open it up in shader graph. This is actually going to be a very easy shader. All we really need is a color. And we'll call this overlay color. Drag and drop that down and plug it into our base color. Under our graph settings, we want to change the depth test to always. And we want to be able to fade this material over time once we hit the wall. So what we're going to do is change the surface type from opaque to transparent. And we're going to need to control this through a property. So we'll go and create a float. We'll call this alpha value. Drag and drop that into our alpha slot. I'm going to give this a default of 1 for a minute. I just want to make a note of this reference because this is what we're going to be accessing through code. Dynamically change this value. Now we've got that, we can go ahead and click Save Asset. And we can shut down our camera overlay shader for a sec. Back in our quad, just make sure that we are actually on black and that the alpha is up on 1 while we test this out. So very quickly, just going to test this shader out. I'm going to hit play. And we shouldn't see, in our game view, we shouldn't see any white coming from this wall. You can see there everything's being drawn correctly. Not getting any of that white kind of clipping as we're moving around, which we don't want to see any wall through or any geometry rendering on top of that fade, which looks like it's working great. And the third part of this is going to be writing the script now, which is going to detect when we've hit a wall and it's going to fade up that quad. So we're going to create a new script, a new C# script. I'm going to call this VR NoPeeking. So go ahead and drag and drop that on our camera overlay and double click it to open up in Visual Studio. So here we are in our VR NoPeeking class and we're going to get rid of our start method. We don't want that. We are going to need a couple of variables. We're going to need one for speed at which the fade occurs. We want to see this in the inspector, so make it serialized field and it's of type float. I'm going to call it fade speed. But also control the size at which we're going to cast a sphere out into the world. The smaller the sphere that we're casting, the closer you're going to be able to get to the wall. We want to be able to control this. Also going to be a float, and we can call this sphere check size. And we'll give this a default value of 15 centimeters, so 0.15f. Also going to need a couple of private variables not shown in the inspector, and this is going to be of type material just to store a link to the material so we're not having to use get component every single time. We'll call this camera fade, and we'll also need another private variable, this time a bool, which is just monitoring if the camera is faded out. I'm going to set that as a default value of false. In our awake method, let's go ahead and assign camera fade mat. Let's get hold of our material. So we say camera fade mat equals get component. We get hold of the renderer on this game object, and we want this that renders material. That's all we're going to need in awake. So we can shorten this down a little bit by clicking on camera fade mat, pressing Control, full stop together, and say use expression body for methods. Then we're going to do a little bit of work in our update method. So here we're going to use an if statement, and we're going to use physics.checkSphere to see whether we've collided with anything. If you hover over checkSphere, it says returns true if there are any colliders overlapping the sphere defined by position and radius in world coordinates. So what we're going to effectively create is from our camera position, we're going to create a sphere, and we're going to see if anything collides from that sphere. And if it does, we can fade up the camera. If it doesn't, we can just leave it alone. So we're going to open a brackets, and we want the sphere to start from our transformed position. And then we can use our sphere check size. This is how big that sphere is going to be. And then we can ask it to test whether we're colliding against any particular layer. So we can use a layer mask for that. So we'll go ahead and at the top, we'll add in another serialized field. This is going to be a layer mask. And we'll call this collision layer. So anything on this layer we're going to collide with. So we can use that as our collision mask. And then you can tell it whether or not you want to ignore triggers in the scene, which we do. We're just going to type query trigger interaction dot ignore. So it's going to ignore anything that's a trigger. And if it returns true, then we're going to create a new method here called camera fade. So let's below our update method. Let's go ahead and create a public void, call that one camera fade. Because we're going to use this method to go from 0 to 1 or 1 to 0, we need to tell it which way we're going. We're going to pass it a float to start from. We have our target alpha, if you like, so we can call this float target alpha, and then put in our little curly braces. So we've got that ready set up. Now we can go back to our update where we're checking to see if we've collided something, and we can now call that method camera fade. Because we haven't yet collided with anything, we want it to go from 0 to 1. We're going to pass it a 1 value, which is our target alpha, so 1f, and then finish off with a semicolon. Now, because our camera's faded, we can say is camera faded out is equal to true. So that's if we're colliding with something like a wall that's going to fade out the camera. But what about if it's not? So we can say else. So just everything is normal. We also don't want to do this every time. What we're going to do is just drop a little bit of a guard clause in here. We can say is camera faded out. That's false, and we don't want to do anything because see there's no big black thing in front of us. So we can say want to just return. We don't want to do anything else at this point. But if the camera has got its quad activated and it's all black, but we're not touching anything, we can say camera fade, and we can say 0f here because we want it to come back. We want to be able to see it, our weld. Go ahead and save that there. That takes care of checking to see whether we've collided something and calling our camera fade method. But now we actually think about needing to write the contents of this method. And all this is going to do is basically control our alpha value on our quad. We want to create a variable here. We can say var fade value, and we can use mathf.move towards. All this is going to do is going to move a value to a current target, which is perfect. That's exactly what we want it to do. So we say move towards, and we want it to move from whatever our current alpha value is on our material. Say camera fade material dot get float. And if you remember when we created our shader in shader graph, we had that alpha reference. We can use that to determine what our current alpha is. So we can say alpha value, I think is what it's called. Let's just go ahead and double check and I'll show you what we mean. Let's open up our shader, and if we click our alpha value, this is the reference here that we're going to use to get this value. So it is underscore alpha value. So back in our script, underscore alpha value. So once we've got that, we want to move it towards our target alpha. We're going from whatever our alpha is towards our target, and it's going to be time dot delta time times our fade speed. and that is going to control that value for the alpha. Then we need to assign this back to our camera fade material. So we can say camera fade material dot set float. Then we want to use our underscore alpha value again. Value we want to pass it, our newly created fade value. We need to keep a track of what this is doing. We don't want to keep fading it out every time it gets to its destination. So we can say if fade value less than or equal to 0.01 f, and we can assume that our camera now back to normal. We say is camera faded out equals false. Save that. So at this point, this should actually all work. It should be good to go. Let's go ahead and give it a very quick test. Make sure we haven't messed something up. Go back to our scene view and select our camera overlay. And you can see here we've got a collision layer. What we can do is go ahead and put these walls on a collision layer. We can go up to layer, select a wall, add layer. Let's just say we call this opaque layer. So we then assign that to our wall, opaque layer, opaque layer. Then on our camera overlay, collision we want to test against, opaque layer. Let's set our fade speed to something like 1, and our fade check size is 15 centimeters. So at the center of this camera overlay, there's a sphere that's being generated uses a collision. We can visualize that sphere, make it easy for us. So back in our VR NoPeeking script, let's drop it down and we can write private on draw gizmos. Give our gizmo a color, so we can say gizmos dot color. It's going to be a new color, and let's make it green. Because this is RGB, we can say 0 for the R, 1 for the green, and 0 for the blue. And let's make it semi-transparent. We go 0.75 f. That's an alpha value. That gives our gizmo a color. And we're going to go gizmos dot draw sphere. It's visualizing the sphere. It's going to be our transform dot position. So this is the center of the sphere, and we can use our sphere check size to show how big this actual sphere is in our game. We go ahead and save that. Back to Unity. I've made my gizmos a bit smaller. You can actually see that's us. This is a sphere that's going to collide with our world. This green one. Just a gizmo, doesn't do anything else and visualize where things are in our scene. Okay, so let's see if this is working. When we've got our layers set up, we're all good to go. Let's go ahead and press play, and all we're going to do is I'm just going to bring this wall and I'm going to drag it into the player. There you go, we started here. See my head moving around, that little green dot. As soon as I drag in my wall, we should start to see the camera fader come up. There we go. As you can see, it's a little slow. We actually see into the wall for a little bit before it actually really kicks in. I'm actually going to make this a little easier for me to test with my headset on. I'm going to bring in my walls. I'm going to fall out my chair when I'm trying to hit the wall. Let's go back to my camera overlay. And let's look at my fade speed. I want it to be a bit quicker. So let's say, let's crank this up to like 6 and hit play. Now when I go through the wall, it shouldn't be such a slow fade. It should be a bit more instant. There we go. So I can't see through that wall anymore. Awesome. No more cheating for me. And then once you've got that set up, this camera overlay, this game object, you can make a prefab out of that. Drag it out of the hierarchy and into the project. And then you've got a cool prefab that you can just export and drag and drop in using any of your games. But let's have a look at how we can quickly move around. So I'm going to right click in my hierarchy. I'm going to go and create an XR. And I'm going to select my Locomotion system action based. Drag that above my XR interaction manager. Looking for an XR origin. I'm going to just drag and drop that in there. I've got a snap turn provider, which we can hook up. I'm going to use my left stick for that. So I'm just going to hit use reference. And I'm going to go to my left hand turn. Find that in the list. I'm also going to add in the continuous move, which is action based, and use my right hand for that. In this list, I'm going to be looking for my XRI right hand move. Go. Now that's going to allow me to move around my scene like so. Let's play this and you can have a look. Use my thumbsticks and turn, and then backwards and forwards to move. You can see it as I move towards the wall. I've got my camera fading in there. No geometry clipping or anything weird, but here's the kicker. I can actually move right through this wall and come out the other side. And a very quick way to kind of fix that, to stop you moving through the walls, go to our XR origin, and here we can add a character controller and give it a radius of say 0.2 and a height of say 1.7. We go back to our locomotion system. For a minute, we're going to use something called the character controller driver. This is going to control the height of our player. We're going to have to put it on here in a minute because it's a bit easier to hook up. So what we want to do is drop our continuous move provider into the locomotion provider slot. Click on the three dots and go copy component. On our XR origin, where we've got our character controller, three dots again, and paste component as new. And it's going to keep that link. It just makes it a little bit easier to hook up. And back on our locomotion system, we can remove that character controller now. So now we've got all that hooked up, we can go back to our VR. That's gonna, having that character controller there is going to block us and stop us using our thumbsticks to go through the wall. If we try and look through the wall, we're going to get our NoPeeking coming up. Hey, no more cheating for me, haha. And then it can move backwards and forwards. So that works great with the thumbsticks moving around. Having that XR controller driver on there is going to help with the height. See, it's changing the height of my collider there. So we're all good to go. But not everyone sits in a chair for doing their VR experience. I know I certainly do. I'm kind of standing up, wandering around. And the second you do that, it's going to move. You can still kind of move away. You can see the collider there in the scene. It's not gone with my camera. An easy ways to get around that is literally just a script. But that's a lesson for another time. What we've got here is a good solution to stop those pesky people looking through the walls and breaking the game. And what we'll do on our next video is actually have a look at stopping them walking through the wall and just wandering off into infinity, breaking your game. So there we go, that's it for this week. I really hope you enjoyed the video and picked up some tips. What we've done there is really something quite cool, and it's going to give you a system that is going to allow you to just drag and drop that camera overlay as a child of the main camera, and it's going to detect if someone's looking through a wall or not. So you can grab this whole entire project from my Patreon page and have a play around with it. And in the next video, we'll take a look at the player just wandering off and walking physically through a wall rather than having to use the thumbsticks for the character controller. So stay tuned for that. Don't forget to subscribe if you're not already, and I'll see you in the next video. Bye guys.